What do you mean the gears from department G29 won't work? I thought they were inspected. Where was inspection? We need to have parts per million quality levels. I'm going to have a word with quality about this. Rodney, Sabina, the gears from department G29 don't work at the assembly operation. Where was inspection? I thought you were looking at these gears.
Dan, I am following our C=0 sampling plan, which usually means a 14-piece sample. Whenever I find a non-conforming unit in my sample, I send the entire lot back to G29. They sort and rectify per our company procedure.
But that's not working.
Okay, hold on. I have an idea. I think we have been focusing too much on the product and not the process. Rodney, do you ever reject a lot?
Sure, once in a while.
Dan, what's the steady-state non-conformance level from G29?
I don't know. We need to fix everything to achieve parts per million quality.
This is like a roadmap. We need to know where we are now, so that we can figure out where we are going. Let's go to the conference room and I can explain my idea.
Okay,
Let's go.
C=0 sampling plans only do half the job. They have great emotional appeal, but will not help us improve our processes. I think our customers have pressured us into making some fundamental errors in the name of parts per million quality. Now we are discovering that cheerleading, and disguising guesswork as data, doesn't make quality better. Let me start by showing the characteristics of our current C=0 sampling plan. By design, this plan will allow a 16% non-conforming lot to pass inspection 10% of the time. It allows a 5% non-conforming lot to pass 50% of the time.
That means the quality of what is accepted is the same as the quality rejected. No wonder we have problems.
I'm sorry, but the story gets worse. The graph on the left shows possible quality levels incoming to inspection, and the probability of acceptance. The graph on the right shows outgoing quality levels. The limit of non-conforming is about 2.5% in stores. As I said earlier, C=0 plans only do half the job. C=0 plans have no mechanism to monitor or improve the process.
It sounds like we should be inspecting 100%.
And I disagree with your statement about the process. We try and get corrective action whenever a non-conformance is made. Sorry I am late. So Rodney, how long does it take your gear checker to inspect a 14-piece sample?
I inspect some other features internal to the machine cycle, review inspection results from the previous part, clean the parts, etc. If you include the time to set up, assure I have the latest drawings, download the latest program, and so on, I would say 2 hours or so.
These gears are fairly complicated.
I know, but this rules out any hope for 100% inspection. We can make the parts faster than we can inspect them.
I have an idea worth considering. Let's meet back in the conference room. If you recall, our existing C=0 sampling plan has an average outgoing quality limit of 2.5%. This graph from the Dodge Romig book shows there are many sampling plans with 2.5% AOQL. The green curve is our C=0 plan. But another one shown in blue is what I would like to discuss. The red line shows all 4 plans shown here have the same equal risk point. That is, a 5% non-conforming lot has a 50% probability of acceptance.
I really do not like that. It bothers me.
And we can fix this over time. For now I think it is important to make sure any new plan has at least the same consumer protection as our C=0 plan. Look at the 10% probability of acceptance. The blue line allows only 11% non-conforming, while the green C=0 allows 16%. Now the good news. We can use our inspection results to improve the process. Here is Dodge's work from 1924. You can see from his P chart that he worked with production supervision to reduce variation over the first 10 points plotted.
Tell us. What does this new plan look like?
The sample size is 32, and we will accept with C=1. We will have a NP chart with 2 sigma control limits. We would only correct the process for an out-of-control condition.
C=1? Who thinks that's a good idea? How can we accept a lot when we find bad product?
I have to agree with Rodney on this one.
Think about it. The C=0 sampling plan is a dumbed down plan. It just isn't sensitive enough to find the non-conforming units. We can't keep our heads in the sand any longer.
Okay, I see the positive points. Let's review this again tomorrow. If we all agree, then we can go live on Monday.
Super.
Good morning everyone.
Good morning Rodney.
Good morning. Can we find somewhere to sit and talk? I think we should review the advantages and motivation for the new inspection plan.
Sabina, what were you saying about C=0 plans only doing half the job?
I found a place here in the lobby for us to talk about it.
Okay, let's go then.
I will show you how we can provide consumer protection and improve the process. We know both the old C=0 plan and the new C=1 plan have the same average outgoing quality limit, which is 2.5%. We cannot be the next victim of cookbook quality, so I think the best way to show the merits of C=1 is to walk through the sample size calculation. Here we see in green, a picture of acceptable quality on the left. Its process average is 1% non-conforming. We will work to improve this, but it is our reality. And on the right in red, you can see the 11% level of bad quality we must guard against. If we want to protect against better than 11%, then this will make the sample size unmanageable, so we should stick with 11%. This is superior to the C=0 plan, which is 16%. Notice that the good process and the bad process overlap. So we will insert a decision line shown in brown. On the left we accept, and on the right we reject. Notice the 5% alpha risk of rejecting the acceptable process, and the 10% beta risk of accepting the bad process. Here are the relationships we will use to calculate the required sample size. First, we know the good and bad processes are separated by 10%. Second, we can use the normal approximation to the binomial to represent the distance from the good process average to the decision line. Last, we will again use the normal approximation to represent the distance from the bad process average to the decision line. Here are those relationships laid out as a formula. Then with some algebra, we can rearrange this to solve for the sample size. Now, we can simply plug in the related values and solve the equation. There you have it. We have just validated our sample size is 32. Since we know the sample size is 32, we can go back to the normal approximation, and solve to find the decision line. We can see that the answer is 1.25. This falls between whole numbers 1 and 2. We will therefore accept on 1, and reject on 2. Here is the good part. We can construct a control chart before collecting data. When we exceed the control limit, then, and only then, will we modify the process as corrective action. We must be careful not to otherwise tamper with the process. As Deming warned, this will increase variation. Now you can see how this ties back to the operating characteristic curve. First, the acceptable 1% process with its 5% alpha risk. Second, the 11% bad process with its 10% beta risk. This plan is more sophisticated than a C=0 plan, but it does require a slightly larger sample size.
I'm confused. What am I supposed to do when I find one non-conforming unit?
You accept the lot, but that unit goes to MRB for disposition.
But there might be other non-conforming units in the batch.
This is no different than a C=0 plan. Just because all sampled units were good, does not guarantee the entire lot is good. The operating characteristic curve and the AOQL tells the true story.
It will be a cultural shift. Currently, corrective actions are like storytelling. There is a lot of fiction when it comes to corrective action.
But we need to make sure we have solid corrective action for the out-of-control points. I am so tired of seeing the same problems over and over.
That's the key point, Rodney. We are moving from hide and seek to real problem resolution and process control.
You didn't say anything about the lot size. Shouldn't the sample size change?
No, the sample size does not change. The binomial distribution assumes a large, or infinite lot size, which is appropriate for making decisions about a process and its infinite potential.
So, let's try and summarize this.
We can't 100% inspect, and we need to improve the gear process.
So we develop a new sampling plan, having the same AOQL as the old plan.
The new C=1 plan will also be used for process control, but requires a 32-piece sample.
We disposition any non-conforming unit found in the sampling process. We reject the lot back to G29 when we find 2 or more non-conforming units. G29 will screen and rectify the lot, and they must implement an effective corrective action.
I think that's all. Do you agree?
One more detail. We must keep a control chart of the sample results. We need to see if the process is improving or not. Later, we can regroup the data into larger daily samples, for increased sensitivity.
Okay. Let's go talk to Department G29 now, so that we can begin on Monday.